Hello guys, this is question 6.8 and the statement of this question is given a normal distribution with mu equal to 30 which is the mean and sigma is equal to 6 which is the standard deviation. Okay, so let me have here this distribution. Let me have it here. Okay, this is what the distribution which we have, and here the mean is 30 while the standard deviation here is equal to 6. Okay, so on the basis of it, what do we have to find out? The normal curve area to the right of x equal to 17. Okay, so let me have here 17 and we want to find out this area, which is now here. Let me have this 17 and we want to find out all of this area. So the easiest way to do is to first convert it into the standard normal distribution, in which this one would be just like 0 and the standard deviation of it will become 1, and then finding out the area by using the probability distribution table, which is called the z distribution table. Okay, we know about it, and then finding it out is very easy because this is the z domain. Okay, so now let us first solve part A of my question, and here first of all transform all of this into the z table, and in order to find it out, we know that for this value of x equal to 17, the value of z would be equal to x minus mu divided by sigma. Okay, so let me first put the value of x, which is 17, the value of mu is 30, and the value of sigma is 6, so it would be minus 13 by 6. Okay, so let me calculate it. It would be minus 13 divided by 6, so it is what? It is minus 2 point, so this is minus 2.17 as given it. Okay, so now this is the value of z, which is here, and this is, let me have it here, let me use another color for it. It is, let me have it here, minus 2.17, and according to the statement of it, we have to find this area which is to the right of it, and this is all the area which is z, or this is greater than minus 2.17. Okay, so in order to find it out, we have here the probability that z is greater than minus 2.17. we have to find it out, but in order to find out this area, we have a table which is in the form of z distribution table, and there we have all the values here, and those all values are written in the form of z less than or equal to minus 2.17. okay, because all of those values are basically the probability that x is less than or equal to z. If we have a formula in this form, we can use the z distribution table. So therefore this area is basically the total area minus this one. So therefore the total area, we know in any probability distribution it is 1, and from 1 we have to subtract this area, which is what? Probability that z is less than or equal to minus 2.17. you can write it z, you can write it x, whatever you want, because these are the values of z. So here I have been using this z. Okay, so let me find out the value of minus 2.17. so let us consult our table. Okay, so this is minus 2.1 in the column. Okay, and the 7 one was here, the 7 is this one, this is the column, so it is 0.015. so let me write it 0.015, and let me subtract it from 1. okay, 1 minus 0.015. okay, so it is 0.985. So 0.985, and that is basically the solution of part A of my question. Okay, so you have understood that how to find out the solution of part A. In part B, let me change the color of it and let me solve it here as well. In part B, the normal curve to the area left to x equal to 22. So let me have here x equal to 22. First of all, let me convert it to the z. So to convert it into the value of z, it would be the similar formulation. So 22 minus 30 divided by 6, so it would be minus 8 divided by 6. Okay, so it is what, 8 divided by 6, it would be minus 1.34. so minus 1.34, which is value of z. Now we have to find the normal curve area to the left of it. Okay, so that is the left, so therefore we don't have to use another formulation for it. So therefore it is probability that z is less than or equal to minus 1.34. we have to find its value, and let me consult the similar table for minus 1.34. so for minus 1.3, this is minus 1.3, and for 4 the column is this one. Okay, this is the column minus 1.34, so it is 0.090. okay, so 0.090, and that is basically the solution of part B of my question. Okay, you can look at it, and this is here. In some books it is also written as this one, but because I have estimated it as 1.34, so therefore this is 0.090. okay, so that is the solution of part B of my question. Let us move to part C, D, and E in our upcoming video. Till then, take care of yourself, and I will see you soon.